Hey there, we are going to investigate the relationship between height and velocity. So let's say you want to know how fast you're going to be going down this ramp, or maybe how fast you're going to hit the water from a high dive. Well, you can do this with just a few bits of information. Now, it's really important to remember that in the real world, there's friction. And so some of the energy is going to be lost as thermal energy. It's transformed from kinetic energy to thermal energy. Energy is still conserved, it's just some of the energy will be thermal energy, and so it's a lot harder to track. Now, our calculations will be close, but they won't be exact. So, to calculate velocity by knowing height, we're going to assume that the system is isolated and there is no friction. So, we need to start by calculating the gravitational potential energy at the start, so at the top of the path. And we do that by multiplying the mass of the object times gravitational acceleration times the height of the object. Energy is conserved, and so the gravitational potential energy at the top is going to be equal to the kinetic energy at the bottom of the path. So GPE top is equal to KE bottom. We know this because if energy is conserved and there is no friction, then there's only going to be potential energy and kinetic energy. And so all of the potential energy at the top will get converted into kinetic energy by the time the object reaches the bottom of the path. Next, we use kinetic energy equals 1/2 mass times velocity squared, and we plug in the gravitational potential energy amount that we calculated from the start of the fall. When we rearrange the formula, we can solve for V, and we get a formula of the square root of 2 times that kinetic energy divided by the mass of the object.